Oh, let's start with question 1 instead of question 4. That'd be good. So these are gas law problems. A gas is enclosed in a cylinder fitted with a piston. The volume of the gas is 2 liters at 0.524 atmospheres. The piston is moved to increase the pressure to 5.15 atmospheres. What is the new volume? Now that we have learned all of the gas laws, all those equations, we have to pay a little more attention to reading the question and figuring out what equation are we supposed to use here. And I think the best strategy for all of these is to first make a table and organize the information. So let's do that. So we'll just make a little table down here. And we'll have a place for condition 1 and condition 2. And we'll just put the numbers in as we come across them. The first number is 2.0 liters. And that is what quantity related to gases? Pressure, volume, temperature, or number of moles? That's the volume, so we'll label that V. The next one is 0.524 atmospheres, and what is that? That's the pressure. And then it says the piston is moved, so this is our new circumstance, to increase the pressure. So we're given another pressure, so we'll write that in that same column, 5.15 atmospheres. And that's all the numbers. So we look at our table now and we see that we have 3 numbers in the table and there's 1 blank square right here. And so this is column V, row 2, and so we'll call that V2. So what kind of an equation do we need? It has to have what variables in it? Pressure and volume. And there's going to be 1s and 2s involved. So if we go looking at gas equations, we'll find one that's P1V1 equals P2V2. So we are solving, we need to rearrange this equation to find V2. And let's just confirm that that's what we're supposed to be looking at. The question is, what is the new volume? So yeah, that matches up. So we're going to take this equation and we're looking for V2. So how do we rearrange that? We're going to divide by what is with it. We're trying to get the V2 all by itself. And it's multiplied by P2, so we're going to divide by P2 because then the P2's cancel out. So that's great, but if we do that to one side of the equation, we have to do it to the other side. So that's how we get our rearranged equation. So V2, we're just going to rewrite the equation so that it's not so messy. P1 V1 over P2. Okay, this part right here, I consider that part of showing your work. So on the other problems, I want to see the rearranged equation with the letters. That's an important step because that's telling you what numbers to pull in. I know some of you like to do stuff in your head, and that's fine after you get really good at it. But it's still always a good idea if the answer matters to write stuff like that down. So include that equation. So we have the rearranged equation, and then we put the numbers in, and we include the units. So pressure 1 is 0.524 atmospheres, and volume 1 is 2.00 liters, and pressure 2 on the bottom is 5.15 atmospheres. And then we always need to look at those units and make sure that they're doing what they're supposed to do. We have atmospheres on the top and the bottom. The atmospheres cancel out. And we're left with liter as a unit. And that's good because liter is a unit of volume. So then we take our calculator. And we have 0.524 times 2 divided by 5.15. And if we look at all of these numbers, they all have 3 significant figures in them. So we're going to report the answer with 3 significant figures as 0.203, and we include the unit liter. And that's the new volume. And then it's a good idea to ask yourself, is it reasonable? Does it make sense? So what happened here? Here we had we increased the pressure, right? And when we increase the pressure, we expect the volume to get smaller, and it did. And so that's reassuring. It's not proof that it's correct, but it's reassuring. So now you guys do the next 2 questions.